Hello guys, let's solve today's GFG POTD. Shortest path in weighted and directed graph. You are given a weighted and directed graph having n vertices numbered from 1 to n and m edges along their weights. Find the shortest path between vertex 1 and vertex n. If there exists a path, return the list of integers whose first element is the weight of the path. Rest of the nodes on that path. If no path exists, return list contain single element minus 1. Return list of edges is as follows. A comma. List of edges is as A node, B node, and weight of the edge, noting there is a edge between A and B. Weight. The driver code here will first check if the weight of the part is returned is equal to the sum of the weights along the nodes of the path. If equal, it will output the weight of the path. Else minus 2. In case the list contains single minus 1, it will simply output minus 1. Okay, guys, let's solve it. First, let's understand the question. Basically, for this question, you need to know Dijkstra's algorithm, guys. If you know Dijkstra's algorithm, no problem. If you don't know, you have to check in online or YouTube anywhere. Know the Dijkstra's algorithm, or I will explain briefly here. You can see here also. So let's start, guys. So basically, assume this is a graph. Okay, handwriting is bad, so uh, let's do it. Mm, Here, assume this is a graph. This has edges, weighted graph actually. So this has edges and weighted edges. Now we have to consider this as a source node. One is a source node. From this one till n are there, right? N vertices. There are n vertices actually. So we have to find the shortest distance to nth. See, this question is see. Let's deal with it simply. Okay. Assume this is a graph. I removed the suppose now n equal to 4, right? We have to return the least distance path. Means to from 1 you have to go to 4 to n, right? So there are two paths. One is direct path 4 edge. Other is direct path like this and like this, right? Which is easier? 2 plus 1 equal to 3 is easier, right? So we'll take this path. So we have to print 431. So that is the answer. So we have to print this path, guys. We have to print this path actually. So where we are coming from, right? So let's start, guys. Let's understand the logic first. Let me for this one, I'll use the extra algorithm. So let's solve it, guys. Now what is the extra algorithm is? Uh, First, I will take a distance array, guys. Distance array. What is the distance array means? There are four elements, right? So one, two, three, four. Okay, I'll remove the remaining. Okay, now distance array, right? See, from first node to first node, what is the distance? Zero, right? We are traveling here from first to fourth, right? So in this distance array, what we are storing is we are storing the minimum distance from node source. Suppose source is this one. From one to one, see, from one to one, what is the least distance? Zero. But one to two, we don't know, right? Still, we didn't iterate anything. So I'll make it as infinity. What does the distance array store means? It stores the least distance between source node and two. Till when we did till the iteration we did. Okay, so we didn't do any iteration, so I'm storing it as infinity. So next I will take a set here. You can take a set. I am using set here. You can use priority queue or anything you want. So I will store two elements. It means I'll use a pair here. In set I'll use a pair. I'll store two elements. What are those two elements? Is one is node, one is distance. Distance means the least means the distance we came from, and the node. Okay. So let's start, guys. Let me start iterating. If you know BFS, you will understand it easily. BFS breadth first search. What I'll do is I'll write a while loop here. Same the extras. If you know the extras, it's very easy, guys. You can check the extras algorithm from anywhere in YouTube. Okay. So while set dot empty. Initially, I'll push set. Uh, Initially in the set, I will push 0, comma 1. what is 0 comma 1 is 0 is distance, least distance, and I'll take a parent array here. Normally in Dijkstra's algorithm, we don't take parent array, but we have to print the path, right? So for printing the path, I'm using the parent array. Same 1, 2, 3, 4. What does this parent array indicate is it shows the distance. I mean, it shows the before node. Means suppose from 1 we travel to 2. So in the tooth index we store 1 like that. We are from where we are coming up, we are remembering it. We are remembering it. So initially we didn't went anywhere, right? We didn't need a iteration. So I'm putting 1, 2, 3, 4. Okay, this is the parent array. This is the distance array. Now let's take a set guys. Set I will store the distance, right? So initially 0 and 1. From 1 to 1 there is 0 distance, right? From 1 to 1 obviously there is 0 distance. So from 1 to 1 I'll initially store 0 comma 1. Now okay, now I'll start a while loop here. While in this while loop, what I'll do is in this while loop till set becomes empty. Means till set becomes empty, I'll start this while loop. Okay. In the set, what is the first element? 0 comma 1, right? Okay. So first one is the first node, right? Now you know two things right here. Here initially the means graph input is given two ways. One is edges way. One is adjacent also adjacency list way. So edges and adjacency list. If they gave here edges, we have to convert edges to adjacency list. They gave here edges, right? So I'll discuss in the code how to convert edges to adjacency list. Now I hope you know what is the adjacency list. Nothing, guys. Suppose we gave here adjacent of 1, it should give us 3 comma 4 comma 5 or 3 comma 4 comma 2 means you're getting my point. 1 means adjacency list of 1 means 1 is connected with 3 and 4 and 5, right? So 3 comma 4 comma 2 it's connected with 3 comma 4. So this is kind of adjacency list. Now while not of set dot empty means set is not empty here, set contains 0 comma 1. So I'll iterate in the adjacency list of 1. In 1, what is the adjacency here? 1 is there, right? So 1 one's adjacency list is 3 comma 4 2 comma 4 3 comma 4. So I'll go to 2 first. I'll go to 2 first. What's the distance here? 4, right? Now initial distance here 0. Initial distance is 0. Now 0 plus 4. Is it less than this one? This distance? Infinity, right? Check the distance of 2. Nothing, guys, easy. Initially distance of 2 is how much? Infinity, right? We didn't iterate anywhere. But I am going, this is the adjacency list here, right? This is the adjacency list. So we are going from 1 to 2 comma 3 comma 4, right? So from 1 we are going to 2. So now distance of 2 is infinity, right? Initial distance of 2 is infinity. Now initially it has means from 1 to 1 it's 0 distance, right? See, from 1 to 1 it's 0 distance. So 0 distance plus we are going to 2, right? Now the edge between 1 to 2 is distance 4, right? 4 is less than distance of 2, right? Distance of 2 means what does this indicate? From 1 to 2, how much distance we are traveling? That is it, right? From 1 to 2, from the source to 2, how much distance we are traveling? Initially, it's infinite. It's less than infinite. So what I will do? I'll change this infinite and I'll put here how much? 4. So I'll put here 4. Okay. And next, where this came from? This 2 came from 1, right? So I'll take this one and put here 1. Why I'm putting here 1? Because I'm storing where I came from. Okay. So and here in the set, what I'll store the minimum distance. What we used to do here. Here distance is 4, right? So 4 comma 2. Okay. Now what I will do next in once one it in adjacency list of 1, what is there again? 3, right? I'll go to 3. So from 1 we are going to 3, right? So 0 plus distance of 3 how much? 2. This edge 2 is less than infinity, right? Initially distance of 3 is infinity here. Is less than infinity, right? So what I will do? Distance of 3 is equal to 2, right? I'll replace it here. I'll replace distance of 3 is equal to 2, right? and I'll replace this as parent 1. We're coming from parent 1, right? Now after this, what I will do? Distance is of 4, and I will push this one here. The distance is 2, and the node is 3, right? Yeah, 3. Next 4, right? Now check 4. Now from 1 to 4, how much? From 1 to 4, what we are doing? 1 to 4, 4, right? 1 to 4, distance is 4. Now 0 plus 4, right? 0 plus 4 is less than infinity. Now what I will do? This 4 is less than infinity. So distance of 4 is 4, right? Least distance. Distance of 4 here. Distance of 4 is 4. I'll place here 4. Now what is the distance array here? It becomes 0, 4, 2, 4. Okay. 1, 2, 3, 4. Okay. Next parent array. From where we are getting 1? From 1, right? So this changes to 1 here. And I'll store this here. What I'm storing is distance. What is the distance? 4. Common node 4. Now again while loop will run. Now is while loop empty? Is set is empty? No, right? Here the set is not. You can understand this in code. Set is not empty, right? Now again it iterates, right? So the first node is 2. It goes to 2. Is there any adjacent node? So it executes and it pops out. So 2 is done. Next element is 3, right? You're getting my point. Next element is 3. Again it goes to 3. Here 3. 3's adjacent element is 4, comma 1. So 3's adjacent list is 4, comma 1. Right? Now time means to travel from 1 to 3, how much distance it take? It took nearly 2, right? Here 2. So 1 to 3 it took 2 distance, plus I'm adding this distance, plus from 3 to 4, right? Means 3's adjacent node is 4. So 3 to 4 it takes distance 1 is equal to 3. Now is distance 4 is less than is 3 or not? Yes, right? 3 is less than distance 4. Are you getting my point? 3 distance of 4 means from initially before iteration from 1 to here, from 1, how much time we took, how much distance we took? 4, right? Initially first we take 1 here, then we went to 2, 3, 4, right? After that we are coming to 3, and we are going to its adjacent elements like that, everything, right? Same BFS traverser. Are you getting my point? 3 is less than distance 4. Now I'll update distance right here. Distance as not distance is here, right? So I'll update as 3. So now the final distance becomes 0, 4, 2, 3. Now also it doesn't stop. Now again we iterated to adjacent elements 4. Now 4 comes into picture like that. Every element, see, from here we are pushing it to the set. From 1 we are pushing it 1 to the set. From initially we are pushing the source node 0, 1. From there onwards we'll push everything into set. We'll go this one, and we'll check if distance is less than or not. If distance means traveling this distance 2 plus, before iteration we are doing initially we are doing not doing any iteration, so distance is infinity, means we kept distance as infinity, there can be a minimum. So when we are traveling it, is there any way while we from 1 we are going to 3, is there any way, means we're adding 2 right here, is 2 is less than infinity or not? Is 2 is less than previous distance or not? Previous, if we traveled any time, it is less than previous distance or not? If it is less than, then we will travel here, and I will rename here distance, and I'll store the parent, right? So that's it, guys. Now they asked you to print the, what to say, print the path, right? So printing the path, everything we have here. Now what's the parent array do? It stores the previous node where we came here, right? So we need to tell 4, right? Obviously 4. So what we will do is I didn't iterate completely here, so uh, so you may get wrong answer. I mean, if I iterate now, it gets wrong. But actually, see here, from 1 to 4, here one path is there, here one path is there. So here 3 will be noted, right? Because means it stores previous index, right? So here 3 is less than, here distance 2, 2 plus 1 is less than 4. So 3 will be noted here. Obviously 3 will be noted here. So now what we'll do is, here 4 is there, right? So 4's parent, where it came from, 4, 3, right? So 3. 3 where it came from? 1, right? So obviously we got the path here. From parent, in parent whatever showing, if it is less than the previous distance, means if current distance is less than the previous distance, we are not in the parent, right? We need for fourth index. Fourth's parent is 3, right? Obviously 3, because here we came from here. So 4's parent is 3 and 3's parent is 1. So we write a while loop here and we'll find out the parent. So that's it, guys. Let's go it out. Obviously we'll code it out. Okay. So let's go it out, guys. First, here edges are there, right? So we have to convert edges to adjacency list. So edges means what they will give from A to B and its weight, right? See here, from node A to node B, edge is there and its weight is W. So for converting it, I'll use vector of vector in a pair. Adjacency list, right? So as one base indexing, I'm taking it here. Now for edges, um, right? So I hope you're getting it what I'm writing. I'll explain it. Let me write it first. Okay, sorry. Here pair, right? So pair. So yeah, basis. Same. I'll copy it and paste it here. But see, it's a undirected graph, right? So it's possible two ways. Yeah. So basically, what is this, guys? What this is, guys? Here, adjacence of IT0 means in adjacency list, IT of 0 means is the first node. And suppose in edge here, what will they give in edge? They will give A comma B comma W. Means suppose 1, 2, 4 they given. Means 1 and 2, between 1 and 2, there's 4, right? Now what I will do is, I'll take adjacent of 1. Means I will take, suppose 4 rows are there. Suppose 5 elements are there. Suppose 1 comma 2 comma 3 comma 4 comma 5. 5 elements are there. One can be connected to these three in any number of ways, right? So I'll write a 4 rows here. One should contain, suppose if I write adjacent of 1, this should contain the elements it is connected with. Suppose this graph is there here. Okay, its graph is not good. So 1, 3, 2, here 4. Suppose this graph is there here. Let me give the edges 3, 4. Now for this one, adjacency list is adjoint of 1 equal to, I'll store pairs, right? So 2 comma 3. 2, 3 is the node here. Okay, so again 2, right? So 3 comma 2. 3 comma 2 means 3 is the weight and 2 is the edge here. Again, it is connected to 3 nodes, right? So 3 nodes, obviously. So 4 comma 4. See, 4 is the node here and 4 is the edge weight. So same. So this adjacency list. So this is what I wrote here. Now I'll use a set. You can use your wish. You can use priority queue also. I'll name it the st set. Okay. Now vector. And what is this is distance. I told you, right? LD means this distance plus 1 comma int max. We don't know anything, right, initially. So I'm assuming it's infinity. Now another one vector parent. It's parent. Parent means parent. I told you, right? Parent previous index shortest path. While if the previous distance is the, if the now distance is less than the previous distance, now we'll store the parent here. Now initially I'm iterating one based indexing, so n nodes I'm starting from one. Mm, right. Parent of I initially I'm initializing with itself. Okay. So least distance of one is initially from one to one zero, right? Obviously zero. Now let me insert SD dot insert. Initially I'm inserting 0 comma 1 because 0 distance on one node from 0 to 0, from 1 to 1 it is 0, right? It will write while loop. Okay, so the auto IT means iterator, guys. Means basically you are writing int, right? Initially we are using int, right? So same that like only int. This is auto means iterator here. Iterator means so now this is this data type. Int data type will be there, right? Auto means st dot begins data type. Okay, int means normal data type. We know it. Everyone know it. So this is auto means that's means it st dot begins data type. Okay, distance. Okay, next arrays, right? See, and means I am storing the initially I took an initially we took here 0 comma 0, right? Means 0 comma 1 actually. So we are storing the distance and the node values. Okay, listing the store I mean pair, right? So I took here it and I'm storing the distance and node values and I'm erasing it. Okay, so it doesn't, we don't need to traverse it again, right? Now for auto it adjoint node, right? Adjacent node. I told you, right, what is adjacent node. It means suppose one is there, the nodes connected with one with their distances, it will be available in adjoint of node. Okay, okay, int neighbor and wait. Okay, I did not second. Now if distance means plus this weight is less than, I told you, right? LD means least distance of neighbor. Initial means this is means previous distance will be there, right? LD of neighbor means previous distance of now means we are showing least distance in the array, so it's obvious, right? So now parent, we have, I told you, right? We'll change the means uh, this parent to node means from where we are coming, we'll store that parent, right? So this is the statement. Okay. Now I hope now we're finding the path now. Complete the iteration. Basically till here the extras algorithm will come. Except this parent thing. This is the extra. Now they asked here path, so we added extra actually. So one. So if it is int max, why this one I wrote here is uh, if LD means if least distance of, if there is no node means initially we are traversing, suppose graph can be like this also, right? Suppose you are through elements yes, in we should travel from 1 to 4, but there is no path here, so we should return -1. The distance are what will store, initially you are storing infinity, right? So the same distance will come here. Okay, now what we will do is we print the path here. Mm, let's name it p means path. Okay, from n, right, means again we'll reverse it. We are traversing, I already told you, right? If this is the path, we'll traverse from here, previous path, previous path, that's path. We'll go like that. Now I'll write a while loop here. Parent of node not equal to node, right? Yeah. So push back node and node is parent node, right? I hope you get it. We're traversing nodes parent, and that node's parent still till it reaches one. Means till it reaches source node. Source node is one. So like that now. This part, what I am adding is mm, source node. Means still source node, right? And least distance here. Means here they asked also. I think yeah they asked here. That's why I am pushing this one. I already did this question once, so same thing. But just we are adding the what we call least distance in the end, and I hope it should run fine. Yeah. So I hope let me check. I hope it should run fine. Where okay. I sorry. Path. I wrote path here. So I took a small variable, or otherwise I initialize this as path. So yeah, it should this much to be fine. Again, we are 1 minute, guys. So I found out, guys. Yeah. So yeah, here some yeah. That's it. I think it should work. Let's see. Yeah, it's working fine. So let me submit it. Yeah, it works fine, I think. Mm, Yeah, it's working fine. So that's it for today, guys. I may upload the extra video. You can watch it if you're free. I'm ending this session, guys.